Recently, I made a video on transmitter and a receiver using LoRa modules, which could give you a range of 10 to 20 kilometers depending on your area. Now, this was the transmitter and it was the receiver. Now, I made it wiring only, so you guys can see it is a pretty massive wiring. So I made even simpler and shorter wiring version that uses ESP-NOW. So this whole thing is the receiver, and this whole thing is the transmitter. Now in transmitter, obviously you have to connect joysticks and a switch. So that was the ESP-NOW based. Even the ESP-NOW based have a range of 600 to 700 meters. Then I moved to the LoRa, which was the longest range I could get. Then I looked equivalent price point of the DIY LoRa based transmitter, and I found two of the transmitters, and this is one of the transmitter that I found. And the second one is a T4B, which is a 4-channel transmitter, and this is a 6-channel transmitter. It also comes with the receiver, and you can see it's a cheap receiver too. Now the major difference I saw is that it uses 2.5 2.4 gigahertz, their own protocol they use for the FlySky transmitter, and it's quite cheap. I think it's the cheapest transmitter you could get at this range. Now I want to see how the range compared to our ESP32 based and the LoRa based. Because it's made in 2008, it also comes with this cable. So you see this is an old cable, and you cannot use this transmitter for the simulation. So if you are thinking of playing phone simulator, you cannot use this type of transmitter. Now for the test of this transmitter, two ways. One is I connected a 3.3 voltage for the receiver, and I checked with the 5 voltage. I used my PWM monitor. I updated the PWM monitor to work with ESP8266, and now I have updated the code to have 8 PWM monitoring on the ESP32 and checked the range. I kept the transmitter inside my car, and I moved with the receiver until I started to get no signal or no PWM from the ESP. You can see the values are showing connected to the ESP inside the car. You can see the transmitter, and that's the place I'm gonna walk. See, the transmitter is working. When I looked back, the receiver started to get the PWM from the transmitter. I didn't go that long, but somehow the receiver started to get some issue with getting the PWM from the transmitter. Now at this point, the range is not reliable at all for a drone, and it's not that long at all. It's like I think 100 to 300 meters. I couldn't believe the range was this short. It was shorter than the ESP-NOW, so I wanted to try again. I'm going to try again with the ESP32. Now it has the required voltage. Previously we had a 3.3 voltage from the ESP8266, so now we have 5 volts. On my second test, it was still the same, so I couldn't believe. So I tested again, tested 3 times, and the result was still the same. So company says it could deliver 1 kilometer range, but according to the users, you will get around 700 on ground to air. But we tested on ground to ground, so it may be because of that. This is the place where our car was situated, and from here we got a little more, so we got this much range. So this is where the range started to get cut off. Now we're gonna check the LoRa based. I have updated the code from version 1.3 to version 1.4, which removes a lot of bottlenecks and increase the efficiency in TX and RX. It's a major improvement. You can try it. If you want to make your own transmitter and receiver based on LoRa, you can watch the video link in description below. So I set it for the 27 megahertz, which is the lowest for the drone controls. 50 is the best one, but 25 is also quite good for drone. So I have set it for the 27. I see the range is already very good. Even with a cheap antenna, it's quite good. In here I place the antenna on its worst orientation, so it will get the lowest range. Even the lowest range of this absurdly high compared to the FS CT6B. And this was the range for the FlySky. When you increase the hertz, you will get lower delay but lower range too. So if you want to increase the range, you have to decrease the hertz. So the acceptable range is considered to be 25 for drone, and 50 is good for if you are having FPV controls. You can use 50 hertz. If you don't know how to find hertz, you will see in the receiver right there, you see the hertz. So for me it is 27, which I have set it for now. Here was the maximum range of the ESP-NOW protocol based transmitter and receiver. So this is the maximum range for the LoRa, but note that this is ground to ground. So if you are going to use on air to ground to air, this is going to be insanely good for your drone. It's set at 50 hertz. This is the standard hertz transmitter and receiver. This was the maximum range of the FlySky transmitter and receiver. Around here was the maximum range of the ESP-NOW. Unfortunately, I lost the video, so I cannot show you how much I got. Even if you choose the 50 Hz of the LoRa, the FS CT6B is nowhere near close to the range of it. Even after placing the antenna in its worst orientation, I was able to get absurdly long range compared to the FS CT6B.